Welcome to our video on application of indices, laws of indices. We have a problem before us, that is 3 to power 2x plus 1 minus 4 times 3 to power x plus 1 plus 9 is equals to 0. So this kind of a problem is not a direct indicial problem, but you need to manipulate it a bit. And when I look at it, I see a quadratic equation, simply because one, it is involving a negative sign here and a positive sign here, but throughout the laws of indices we never defined the two signs, negative and positive. We only had multiplication and division, whereby if you had two numbers multiplied and they have the same basis, you added their powers. And if you had the two numbers whose bases are the same, you dividing them, you subtracted their powers. But this one is a different case altogether, but let's see how we go about it. So let's get started. So we're going to have 3 to power 2x times, this is our solution now, 3 to power 1, splitting them, minus 4 times 3 to power x times, remember I'm using dot to present multiplication, times 1 plus 9 is equals to 0. So when you do that, you will say let 3 to power x be equal to m. You can choose any letter if you want, but my choice is m, not because it is the best, but it's what I've chosen for this time. So here seems like I have m squared, so I can have m squared times 3, so I have 3m squared minus 4 times m times 3 plus 9, which is equal to 0. So this number reduces, this expression reduces to that minus 12m plus 9 is equals to 0. So by 3, if you divide by 3 everywhere, you now get the quadratic equation I was talking about, plus 3 is equals to 0. Solving this, you'll have product is 3 and sum is minus 4. Those numbers are minus 1 and minus 3, because when you multiply them you get 3, and when you add them you're going to get negative 4. So m squared minus m minus 3m plus 3 is equals to 0. Solving this, factor m minus 1 minus 3 into m minus 1, answer equal to 0. So either m is 3 or m is 1. Now, in the beginning I had said that let 3 to power x be equal to m. So I can go back there because I'm not interested in m, I'm interested in x. I'll say now 3 to power x is equals to m, and in this case I begin with 3. And you notice that 3 is like 3 to power 1, yeah? Written in power form. So we have x is equals to 1. That's very important. Now the other value is 3 to power x is equals to 1. Now this is a bit tricky, but you can visualize it this way. Any number raised to power 0 is 1. So even if I were to put 3 to power 0, the answer is still 1. But now 3 is equals to 3, therefore x is equals to 0. So I have x equals to 0, and that again is another value of x. So these are the answers for our equation here. There are two things I want to point out. Study your equation carefully, see which infrastructure you're supposed to apply, because the nature of a problem will suggest again the kind of approach you're going to make. So look at the problem, study it closely, check what it requires. Then at the end, verify to see that the answers satisfy the condition given. So if I put 1 here, I'm going to have 2 times 1, that's 2, plus 1, 3 to power 3 is 27. Then I have here 1 plus 1, that is 2. 3 to the power 2 is 9. So 9 times 4 is 36. So 27 plus 9 is 36, minus 36, the answer is 0. So that checks out. Now we have, if you have x is 0, then you substitute here that you have 2 times 0, that's 0. So 3 to the power 1, 3. Then you have 0 plus 1, that's 1. 3 to the power 1, that's 1 times 3, that's 12. So you're going to have this is, we say 3 to the power 1 plus 9, that's 12. 12 minus 12, 0. Again, this x equals to 0 is valid for this entire problem. So these are the two answers for this. Thank you.